So let's look at the MCQ review for the enzymology lecture. Question 1 says, in the Line-Weaver-Burk plot, the Vmax of an enzyme is well. So if we draw the Line-Weaver-Burk plot like this, here it represents the inverse, that's the Vmax, that's this point here, and here represents this point of intercept at the x-axis is the -1 over the km. So it's the reciprocal of the absolute value of the intercept of the curve at the y-axis. So this is the y-axis, this is the x-axis. So this is the answer, option B. Question 2. The chemotherapy drug 5-fluorouracil undergoes a series of chemical change in vivo that results in a covalent complex such that it is bound to both thymidylate synthase and methylene tetrahydrofolate. The inhibition of deoxythymidylate formation and subsequent blockade of cell division is due to the following. Now, the watchword to see here is covalent complex. So when a covalent complex is formed, that is irreversible inhibition. Question 3. The active site of an enzyme is, the answer is it binds to competitive inhibitor. That is the most appropriate answer for this question. Question 4. The velocity V of an enzyme catalyzed reaction is what? Decreases as substrate concentration increases. That's not true. It's slowest when the enzyme is saturated with substrate. Is related to the substrate concentration at 1 over Vmax. Yes, and that point is called the Km. A competitive inhibitor of an enzyme will do what? Increase Km but does not affect substrate. That's also correct. That's actually correct. So it decreases Km but does not. This is wrong. It increases Vmax. That's wrong. It increases Km but does not affect the Vmax. For question 6 to 8 now, consider a reaction that can be catalyzed by one or two enzyme A and B, with the following kinetics. So this is the enzyme A. The Km is 5 times 10 raised to the power minus 6, and this is the Vmax. So if we could draw this now, let's draw it with a Michaelis-Menten diagram. So this is the Km would be this point for A, which is 5 times 10 raised to the power minus 6, and the Vmax for it is 20. So which means if this is the Vmax 20, the Km will be half of the Vmax. So it will be half of the Vmax. That's where the concentration will meet each other. So the Km is the value at half of the Vmax. So the Vmax will be 10. This is for enzyme A. This is the substrate concentration. Then for enzyme B now, if we draw it, the Km is 5 times 10 raised to the power minus 4. The Vmax is 30, so this is the point 30. So invariably, what that means is that the half of the Vmax should be 15. So let's use this information now to answer the question. Question 6 says, at a concentration of 5 times 10 raised to the power 6 mole, the substrate, that's 6 mole substrate concentration, the velocity of the reaction catalyzed by enzyme A will be what? It will be 10. So that will be the answer, A, 10. Question 7. At the concentration of 5 times 10 raised to the power minus 4 moles of substrate concentration, the velocity of the reaction catalyzed by enzyme B will be what? Will be 15. So that's the answer here. So at concentration of 5 times 10 raised to the power minus 4 moles substrate concentration, the velocity of the reaction catalyzed by enzyme A will be what? Now if this is 5 times 10 raised to the power minus 6, if you multiply this by 2, that will give you a value of about 10 raised to the power minus 5. So if at 10 raised to the power minus 5, the Vmax has already been achieved. 5 times 10 raised to the power minus 4 is higher than 10 raised to the power minus 5. So even if we increase the substrate further, the Vmax will still remain the same. So the answer to this is still 20. Question 9. The addition of ammonium sulfate makes it possible to separate proteins from a mixture according to their degree of solubility. The saturases E6, that's oxidative reductase class, are enzymes that catalyze the introduction of double bonds into a hydrocarbon portion of fatty acid. That's the answer, option A. A plot of 1 over V versus 1 over S which allows more accurate determination of Vmax and Km, is known as double reciprocal plot. That's Lineweaver-Burk plot. Which of the following represents Michaelis-Mentel's equation? The answer is A. A metabolite that binds to the allosteric site of an enzyme and alters its kinetic characteristics is known as a modulator. Inert molecules that are transformed by enzymes at their active site into reactive substance that inversely inactivate the enzymes are called suicide inhibitors. An example is the reaction of allopurinol with xanthine oxidase, converting into alloxanthine, which further inhibits the enzyme xanthine oxidase. So suicide inhibitors is the answer, option C. Then question 15. A worldwide pandemic of influenza caused by human adaptive strains of avian influenza or bird flu is a serious health concern. One drug was for treatment of influenza, Tamiflu, oseltamivir, is an inhibitor of influenza virus neuraminidase required for release of the mature virus particle from the cell surface. Recent report has raised concerns regarding viral resistance of Tamiflu, compelling the search for alternative inhibitors. Another drug, Releza, that's zanamivir, is already FDA approved for use in a prophylactic nasal spray form. The graph below shows the kinetic data obtained for viral neuraminidase activity measured as the release of sialic acid from the model substrate as a function of the substrate concentration in the presence or absence of Relenza and Tamiflu. Now, Relenza, you can see there's no cross, as we said. This is the control here. This is the green line is the control. This is the actual control. There was no inhibition at this stage. Now, when we added Relenza, Relenza raised it decreased the Km. This is an inverse, so it decreased the Km, but does not affect the it decreased the Vmax, I meant to say, but does not affect the Km. This is 1 over Km. This point here, the Vmax. So Relenza is a non-competitive inhibitor. So don't forget, I said non-competitive. NC means no cross. It doesn't cross. There's no cross formed. But Tamiflu, on the other hand, the Vmax remains the same, but the Km was increased and there was a cross. So Tamiflu is a competitive inhibitor. So let's go to the option now. Based on the kinetic data, which of the following statements is correct? Both drugs are competitive, that's false. Both drugs are non-competitive, that's also false. Tamiflu increases the Km value for the substrate compared to Relenza, that's the correct answer. So that's the end of our MCQ review on enzymology.